wasn't expecting to have to do this. This engine assembly grease is so good, it was so thick and laid a nice coating on the bearings that I literally had to put this in a bowl with some detergent and clean and brush off the oil off of each bearing just to get it clean. Lesson learned, what I should have did was wipe them off first and got them as dry as possible. Maybe a teeny bit of carburetor cleaner. Don't want them to get too dried out or brittle. But either way, clean them off first, get as much oil off as possible, and then put them in your sonic cleaner. So, lesson learned. Now I'm going to put them in there again, let it go for maybe one cycle because they're already pretty clean, and then we'll be good to go. Damn, these piston oilers came out looking good. I mean, they're all shiny. They actually look like these things are new, just from cleaning all the residual oil off it and running it through the ultrasonic cleaner for about 3 minutes. These things look good. Just wiped off all the crankshaft journals. Now I'm in the process of installing the piston oilers. And I ran the oilers back through the sonic cleaner, so they cleaned up very good. And then I'm lubricating them with a little bit of fogging oil. This is pretty good. Use this and reinstall these back into position. And pushed each one back in to make sure they're fully seated into each one of the crankshaft journals. And of course, there's 6 of them, even though you have 7. This is the extra support, the rear end supporting the crankshaft itself, where the flywheel, timing chain, and everything bolts up on this end. But this is pretty good that the Volkswagen engine block actually has 7 crankshaft journals itself, crankshaft main bearing caps, where a lot of V8s doesn't even have 7. Main bearings installed, tangs all lined up, and of course you want to make sure you install the ones with the hose in the engine block itself, so that way when the oil is lubricating, it can get through the bearing and lubricate the crankshaft as well as lubricate your piston squirter. Even though the piston squirter itself, as you can see, it has a notch out, so even if you did put the wrong one, which you do not want to, oil would still get to your piston squirter, your piston oiler. But if you block this off with the wrong bearing, it would not allow oil to get through to lubricate your crankshaft journal. So make sure these are the closed end. These go for your caps, and the ones for the hose actually allow for the oil to get through to lubricate that crankshaft. And of course you want these to be installed dry, so that way when you go to measure the clearance using your plastic gauge, you don't have any interference or oil that can cause any type of misreading. Now you want to definitely make sure when you install your crankshaft, you install it, keep it in a fixed position, and do not rotate it because you can mess up the plastic gauge. In this crankshaft, so I'm about to remove the dual mass flywheel. You can see that this originally had the little small, and I've mentioned it before in previous videos, the small roller bearings for the pilot shaft. And that would be similar to the one I was originally going to install. That small one comes in the Volkswagen. Usually the DQ500 transmissions, a lot of the manual transmissions that may have a pilot shaft tip that sticks out that'll go into the crankshaft, like my Quaife racing sequential transmission, that'll stick out off the end, that'll keep this main shaft real stable as it goes into the crankshaft. And of course the Porsche that has longer roller bearings, this will of course cover more surface area for more stability, but we're going to go for the ultimate, which would be the bushing itself, the brass bushing. This is for extreme use, and hopefully, well, not even hopefully, we're going to be putting this crankshaft, the whole engine, through some extreme usage with testing out parts, seeing how far we can push the stage 1, and we're going to push it. So in this application, we have yet to test any of them, but for this stage 1, we're going to be starting off with this. So initially we purchased this, which is brand new. Was about to install it. That's why I have T in there for Teddy. Never got to it throughout research. Ended up coming up with the Porsche one, and did install that in the previous cast crankshaft. But now that we're going with the forge, then we're going to go ahead and start off with the brass bushing. I have the cover plate off of the dual mast, so I'm ready to take off the ARP bolts, and then that way we can prep to lay the crankshaft into position. I have all the ARP main studs in position. You can still see the plastic gauge on each one of the journals for the crankshaft, and then I'm going to just slowly position each one of the bearing caps in the proper location. Gently sliding everything down in position, making sure that I do not rotate the crankshaft whatsoever. Everything has been dried off, and that way once I go to torque it down to spec, I'll have an accurate reading to make sure I have the proper clearance that's rated for the factory blocks. And I usually run the hardware down pretty slow at this stage just to make sure there's no vibration or the plastic gauge doesn't shift from off the crankshaft. Pretty much the same procedures as before. The ARP fastener assembly lubricant on the threads, as well as a little bit on the washers and the backside of the nuts. So that way, once this is torqued down, it'll reduce the friction and allow for proper torque specification. Following the factory specifications, along with using ARP's recommended torque, I torqued each one of the nuts down to 60 foot-pounds of torque. Next step is to remove all of our hardware and take our time to remove each one of the main bearing caps, and that way we can check out clearance for the plastic gauge. So we are looking good according to specs. I checked each one of the journals and everything checked out good. So we have a specification that we can go for anywhere around 0.02 to 0.06 millimeter, and everything is hitting for the most part. Let's zoom in on this baby. We're somewhere at 0.038, which is pretty good. We're in the middle of the spectrum, so that's pretty good bearing clearance for starting off. Let's go ahead, clean this baby up, and continue to work with it. Using a little break-in oil, lubricate my piston ring compressor, and I'm starting off with the number 1 cylinder to push the number 1 piston in position. Let's get this baby in. We got 1 in, baby. 5 more to go. Let's get this bad boy in and put back together. Making some good progress with the short block. We have 5 of the 6 pistons in, working on the last bad boy. So each piston, I've taken the time-consuming process of making sure I have the proper bearing clearance with my connecting rods. So we're down to the last one. That would be number 5, if I'm not mistaken. I'm sorry, number 6. The last one, number 6. And once we get this done, we'll be pretty much finished with the bulk of the work with the short block. We can then start setting up to bolt the cylinder head onto the engine block and making preparation to work with our timing chain gear. So I'll rotate this over just so we can get a top view of how this looks. My last set of bearings just got finished cleaning in the ultrasonic cleaner. We'll take them out, make sure they're all dried up, wiped off, and put them in to check out bearing clearance, and we'll be good to go. So engine's rotated back over. We'll drop this last piston in position. Push this baby down in the hole and get prepped for measuring our last bearing. And then we can go through the process of getting this thing ready. A few upgrades that I was making over the process. Some things I had mentioned before. Tracking down the aluminum coolant pipeline. That part comes off of the exit port right here for the water pump. Originally we had the original factory plastic one, so we've come across a lot of nice products. We got our cam bolts, our ARP cam sprocket bolts. Cam sprockets are sitting over there, so you'll see all that in the video. But either way, it's getting late. Let me drop this last piston in, check the clearance, and we'll pick back up on this tomorrow. We finally got this last piston installed. Got my plastic gauge in position. So we're ready to just go ahead and measure the clearance. We're looking for a clearance of 0.02 to 0.07 millimeter. All my piston rings have been installed and the correct orientation. So let's get this last bearing measured out. We should definitely have proper clearance. Everything else checked in good. Down to the last one. Let's get it and keep moving forward. Okay, we have two potential beasts sitting right here in front of me. They've been picked up from the machine shop this morning. These are for our stage 3 builds. One will be for Teddy's TT and the second will be for my S5. That S5 right there behind Teddy's TT. So they're right in line, sitting there ready and waiting for our stage 3 build-up. So these will be receiving our JE pistons that's totally customized for our special treatment. One of the things is that these will take it to another level and we will really see how much horsepower these VR6 can handle with our stage 3 setup. And this will probably be the next stage before moving up to a billet block. So next step, drop these off at my primary machine shop. As I stated, we'll get these honed out for our special pistons and start building some backup engines. Backup for Teddy, primary for my S5. Okay, I'm back at it. I am lubricating each one of the ARP bolts, the rod bolts, with the ARP fastener assembly lubricant. I'm lubricating the bottom side of the bolt itself as well as the mounting surface on the back side of the rod. So I've double checked all of my rod bolts as well as my main bolts just to make sure everything's been torqued down properly to spec and everything is rotating over nice and easy, as it should, because the only thing we changed in this application for the most part was the crankshaft. So everything is rotating smooth, nothing's bound up or tight, and we can rotate this engine over and pick up on the cylinder head. Before proceeding with the cylinder head installation, I decided to go ahead and install my sump pickup as well as my crossover tubes. I used a little bit of medium thread Loctite to make sure that my bolts were secure. You do not want these to vibrate out. Most definitely you don't want any possible oil pressure losses. You want to make sure that all of this seals up right. If there was any type of leaks in between here, of course it's not going to have proper suction from out throughout the screen section right here. So wanted to just make sure everything was secure, locked down and tight. So now we can rotate this engine over and proceed with the cylinder head installation. Okay, the engine's been rotated back over and I align my crankshaft to TDC. And how you can tell is the chamfer tooth is the tooth that's slightly chopped off right there. I align that with TDC that is lined up with the crankshaft. So where the main cap bolts to the block, you can see this seam right here. When you align that, your engine is at TDC. And how I can tell, come up top, you can see your piston is at top dead center, number 1 piston. And my oil pump, I aligned that too. This oil pump, you want the flat edge right here aimed at the pointer. When I get the sprocket, you'll see a hole also that'll kind of line that up. But next step, I really want to get this old pilot bearing from out the crankshaft. You can see that one has the smaller roller bearings. Now I purchased a pilot bearing removal tool. We'll see how good that works with removing these out. I've never had to remove one out, and that one has the smaller roller bearings, as you can see in here. Now I'm going with a nice pilot bearing. The reason I'm like grinding, I'm not sure how much I want to reveal because a lot of these parts we want to test it out. But either way, we'll see if I reveal what type of bushing I'm installing. But let's try to get this old one out of here. Sad part about this, I've been fighting to get this bearing out for well over an hour. I would have had the cylinder head bolted on in place with the timing chains on if I wasn't fighting to get this pilot bearing out. But I'm not giving up on it. It's got to come out, no ifs, ands, or buts about it. This crazy pilot bearing has been fighting me the whole way. I've tried to use a tool, a couple tools. These tools are set up, you can remove bearings. This was a specific pilot bearing tool that I bought. Neither one of these worked. I tried using a slide hammer and going through the center hole, and everything just kept reaming out into the holes getting bigger and bigger. This is in here. I may not have any choice but to grind this out, which is just crazy ridiculous. But either way, it's going to come out one way or the other. Of course, I try to chisel, to try to slice it, everything. Of course, it's a nice heavy duty grade, probably stainless steel, and it is in there. So I fought with this long enough. I decided to drape the whole engine block in a trash bag and cut this out. Next time, I will remove it before I have it balanced or even install it into an engine block. So therefore, if I have a crankshaft that comes with a pilot bearing already in there, forged crankshaft in particular, I will remove that before I start my engine process because this thing is in there. So I don't want to get metal filings anywhere on or inside the engine. So drape it in the plastic and let's go ahead and start cutting this out. Needless to say, this was a pain in the ass trying to get this out. I had to slice it and then, of course, as you can see, run a longer bolt through it. And now I'm actually pressing this out by threading a bolt into it. So this took a while. I lost a tremendous amount of time doing it, but lesson learned. At least I got it out. So this was, like I said, definitely a pain. Pilot bearings out. I'll go ahead and just pull it on out with some pliers, clean up the port, and press in a new one. So it was most definitely a pain in the rear getting out the original pilot bearing. Cleaned all the metal debris up, blew it out with an air gun, and now let's get into new. So I have my bolts torqued down into position for the tensioner, and of course I use green Loctite on them just to hold them in position. My oil pump bolt, that had to be torqued to 44 foot-pounds of torque and then rotated 90 degrees. So I drew a mark across it with a paint marker, and that way once I rotated 90 degrees, my mark should line up. I have my lower timing chain on. Everything's timed and marked out good. Okay, we're back at it. We're getting prepped to set up for the solid lifters. So I'm starting off with the intake camshaft. I'm going to probably start off with my own custom lash, and then maybe once we go to the stage 2 setup, we'll be using these just like we're going to use for my stage 2 setup. But either way, let's get started. Let's get the camshaft out, take these lifters out, and start prepping for our lash adjustments. With this test, we're looking pretty good. So I installed the original springs that came in the hydraulic lifters. I disassembled the hydraulic lifters, had my own special lash shims, and we're looking good. And with the springs installed, that'll reduce valve train noise quite a bit. I can get in here in between the base circle of the camshaft and the roller, and we have great clearance. With 10,000, this is a little too tight. If I try to force it in between, you can see my cam is rotating over. It's actually spinning my cam over. The cam is no binding. I can rotate this by hand, and this is good. My rollers are up nicely against my camshaft. So this will reduce a lot of the noise as well as give it a nice, secure operation in here without the extra noise going through the valve train or the engine of the car. So what I'm going to do also is I had took the C-clips off of this one, and this is an example. And here's the original one. And these still have the little clips on here, the little snap rings or C-clips. That helps lock this into the bottom part of the bucket itself. So what I'm doing is I'm using the springs at the bottom. I'm using my lash caps. These right here, I have different ones. I can shim these down. These are all custom made. I can shim these down to a custom setup, or I can really just disassemble part of this also so that it's hollow. I took out the spring and the ball valve itself so that I can use just this hollow bottom and let my spring fit into this housing with my own lash. These work great, and we're going to give this a shot. So I'll lock these back into position. I'll do a test fit on everything. If everything fits properly good, then I'll use these, snap it back into the bucket, and I will have changed the factory hydraulic lifters over to a solid lifter setup. It's quite a bit of lift that's being lost using the factory hydraulic lifters, and I was actually surprised how much. Just doing a test with the solid, I'm like, wow, day and night difference. So that's a big performance gain right there. So let's continue with the flow, see how far we can get, and get this bad boy set up for some solid lifter action. We're looking pretty good. That's it for the night. It is 1:43 a.m. Check that out. And it is late. Later than I wanted it to be. But anyway, we got it done. Last cylinder, that's 8,000. It fits in there nice. Very good. No binding. If I try to stick my 10,000th in there, a little too tight, won't even fit in there on either side. So I had to lash this out. Had my own little documentation of each one of the cylinders, and we turned out really good. So, next step, go ahead and clean everything up. I'm going to do a little bit of modifications to the lifters itself, so that way we can get a little bit better oil flow, oil control to get to the top part of the rocker arms. And that's it. So, let's wrap this up, get some late night dinner and pick back up on this in the morning. So since this car will be daily driven also, I have the springs installed in here with my shims, so therefore you can see it's still functioning as a solid lifter. Once it's installed, it'll be compressed against the solid lash cap. The spring will allow for adjustments, which will be good for a daily driven, so that'll help reduce lifting noise and still allow it to function as a solid lifter. Once that cam is installed, this will compress down against the bottom part of the lash cap or the top part. Either way, and that way this will be a solid lifter functioning. As things start to wear out, the spring will start to take adjustments for any type of lifting noise and reduce valve train noise and still allow it to function. And then all we have to do is just continuously check for our lash adjustment in between runs and races. But bottom line, the car is still going to be daily driven, and that'll help reduce the noise for a daily driver. I decided to use my sanding tool and buff out, flatten out the two sides of the lifter piston itself. That way that'll help break the seal. So by me pretty much machining a flat spot on both sides of this, that'll help break the seal, so that way it'll reduce any chance of this pumping up. So that, along with the reliefs at the bottom to allow for the extra oil control, I think this will work out pretty good. So I'm using that my cutter to notch the bottom sides of this, as well as my air gun just to blow out any type of debris or particle from me doing any type of grinding or machining. Finally finished performing all the modifications to the factory lifters to turn them into solid lifters. And if your question is, why didn't I use the solid lifters? These are specially made for solid lifters, and the reasoning for me not using these is simple. I didn't have enough lash caps. I had the intake and exhaust cam both installed. This time around I used green Loctite to secure all the hardware that mounts the camshafts in position. Normally I was using the red Loctite, but I got tired of the red Loctite gripping the studs so hard that upon removal some of the studs would just pull completely out of the cylinder head. So I installed red Loctite, put the studs back into the cylinder head, and then I'm using green Loctite on the hardware itself to secure the cam caps. I'll repaint and mark each one just so that way I can gauge the position of each one of the nuts to make sure nothing rotates off. Also, I'm about to install my cam VVT housing right here. This time around, I'm going to remove the screen. There's been a lot of problems with apparently screen failure. It was a later model VR6 engine I removed out of a vehicle from the salvage yard also, and surprisingly, I was like, what the heck? I found the screen actually jammed into the timing chain. So upon my research, I apparently discovered a few vehicles, these will break off and can clog up the housing, mess up the adjustment for your cam controller, as well as break off and get jammed up in a timing chain like what I found. So we're going to remove this thing this time around and get this sucker out of here. I'm not going for that this time. I'll get this pick and just go ahead and pick it out, install that, and mount this back into position. Make sure that my ceiling rings are clocked 120 degrees apart. I'm going to adjust these, make sure they're rotated around, and I use some assembly lube in the housing and push this in position. So I installed assembly lube around the inside of the VVT housing, especially around this tapered edge, because this tapered edge is actually what compresses the rings, helps them to compress while you're sliding this in position, as well as using break-in oil on the rings itself, so that this can help and give a little extra lubrication while sliding this into position. All right, we're looking pretty good. Of course, I'm gonna lube this brand new sprocket. All this stuff is new. You can see this is just new because the engine hasn't even been run yet. This cylinder head is heavy. I mean heavy. Two people lifting this and setting it back on the block would have been tremendously easier, but I managed to straddle over top of the engine stand and lower it slowly using a lot of upper body strength. I'm taking my time, meticulously going through step by step to make sure everything is set up properly, all the bolts torqued down, marking everything, lining all my gears and timing marks up, and it's working out pretty good. So let's get these bolts, 1/2-inch studs, threaded in position and torque the head down into place. That structure part cracked, which is not good at all. Hard lesson to learn. Being the first to do something is not always necessarily good. And I recall saying that before, but it cracked in a couple different places, and you can see that top tower is breaking away. That is not good. So we're going to have to probably use the backup head to finish this. And right there is where we are making contact with the valve spring. So eventually this whole section could break off, fall down, and the debris could get trapped in between that valve, keep it stuck open, and hence catastrophic failure. Damn. Oh, I am not pleased. That messed up my whole night. Or morning per se. 4:34 in the morning. I'm going to wrap it up and come back with a game plan of using the backup head. I have the backup head already sitting over here, 2 of them, one for my TT and Teddy's backup engine. So we don't have no choice but to go ahead and use this and less torque. So I'll probably end up sticking with 90 foot-pounds of torque.